students, in this module of the chapter Gravitation, we'll be discussing about total energy of the satellite and then the binding energy of the satellite. Let's start with the first term, that is total energy of the satellite. Now, you know, when a satellite is revolving around the earth at a height, because of the height it has got some potential energy, because it is at a height inside the gravitational field, and also because it is revolving in a circular path, that is, it is in motion, it has got kinetic energy. So just summing up, I can say for a satellite revolving around the earth, there is potential energy which is given as minus gmm upon r plus h, and on account of motion it has got kinetic energy which is given as gmm upon 2 r plus h. So in this case, the total energy of the satellite would be the sum of the potential energy and the kinetic energy. So if I just substitute the values, I get it as total energy is equal to minus gmm upon r plus h plus gmm upon 2 r plus h. You can notice gmm upon r plus h is common. So inside the brackets I'll get minus 1 plus half. Minus 1 plus half is minus half. So totality, I get the expression as total energy is equal to minus gmm upon 2 r plus h. And this is the expression for total energy of a satellite revolving around the earth at a height. Now we come to the next part, that is binding energy of the satellite. Let's understand the definition of binding energy. The minimum energy which must be supplied to a satellite so that it can escape from the gravitational field is called as the binding energy of the satellite or of the object. As the name suggests, binding energy, bind, the energy with which it is bound inside the gravitational field. So if you want to release it, that much energy with which it is bound, we'll have to give it in an opposite way so that it can escape from the earth's gravitational field. Remember, mathematically, binding energy is always equal to minus of the total energy. So now let's find out what is the binding energy. For that, just recollecting, what is the total energy of a body or a satellite revolving at a height? You remember, the total energy is the sum of the potential and the kinetic, which is nothing but equal to minus gmm upon 2 r plus h. Now if this is the total energy, mathematically you know that the binding energy is minus of total energy. So in this case, the binding energy will be equal to minus of total energy, that is minus of minus plus. So plus gmm upon 2 r plus h. And this is your binding energy of a satellite revolving at a height with respect to Earth.